Hello again. Yes, this is actually my second attempt to make this because the first time my daughter decided to start crying halfway in between. She doesn't want to sleep tonight. So, yeah, you asked me to go over these equations with you. They're actually just all quadratics in disguise. So, to solve these equations, all you have to do, well, I say all, but what you have to do is solve quadratics or factorise them. You're probably going to get quadratics that are easily factorisable or meant to be anyway. So we're going to use the same technique that I actually showed you in the previous video where I showed you how to solve a cubic and then you had to factorise a quadratic. Same thing, so we're going to do the right hand column cross left hand column. So the first one we can look at is x squared minus 4. You might know what that is anyway, but I'll just talk you through the method. So first thing is the right hand column, we need two numbers that multiply to give 4 or minus 4, so that's 2 and 2, or it could be 4 and 1, but let's try 2 and 2. It's going to be a plus and a minus to get the minus here, and then left hand column x and x. You might remember that there's a cross part here, which would give us the x term in the middle, but there is no x term. Why? Well, because that's plus 2x minus 2x cancelled out to give 0, so you just have minus 4 x squared. Well, that's known as the difference of two squares, so you probably have seen that song before. So why have I shown you that? Well, because the first problem is exercise 3.4 or 3.6 actually was the same question, so it's difference of two squares. You have two numbers that multiply to give that, or two things that multiply to give that, which is 2x and 2x. Again, plus and minus because you get a minus. And then to get s, that's just going to be s and s. So s plus 2x, s minus 2x. So that's the first one. The one you sent in the group, yeah, I didn't recognise it because it was different to the letters are different, but it's the same thing. So we're just going to see that it's exactly the same. There it is. Using this one first, so just going through this one quickly. So again, we want to figure out what two things multiply to give 2. Well, probably 1 and 2. Since it's a prime number. I don't know that it's going to be plus yet, but this is where this part comes in. So 1 and 2 adds to give 3, which is what we've got here, so I know it's plus 1 or plus 2. If it was minus 3x, it would be minus 1 and minus 2. So it's not that, so it must be plus, and then to get x squared, I need x and x. So just checking that, I've got right hand column, 1 times 2 is 2, and the cross of 2x and 1x, so that adds up to give the 3x, and then left hand column x squared. So we're going to do, it looks a lot worse, but we're going to do exactly the same thing for this. We've got x squared, got an x, and got a number. Just don't know what the number is, that's all. So to get minus a, how are we going to get that with two numbers? Well, we need a 1, a. 1 times a, yeah. And then to get 2bx squared, so just skip into that part, to get 2bx squared, the two things we need to multiply in the left hand column are going to be 2bx and x. So the right hand column, that's going to give us a, and we need to figure out where the minus sign is going to go. And this one, left hand column, that's going to give us 2bx squared. So then it's just a question of, alright, have I got this the right way around? So if I put a plus and a minus there, that's going to give me minus a, that's cool. And then I've got minus 2bax, that's not what I've got here, and plus x, no, that's not what I've got. Okay, so I just need to jiggle those around a bit. So, in other words, I just need to put x at the top, and 2bx in the bottom. Okay, so let's go plus and minus. I could try minus and plus there, but I'll just try plus first. So it's still going to give me minus a. Here I've got minus ax, okay, and here I've got plus 2bx. Is that what I've got here? So I've got minus 2bx there. Is that what I've got? Nope. And here I've got plus AX. That's not what I've got there either. So I've also got to change these around. So that should be a minus. And that'll be a plus. So this time AX plus minus AX, yes. And then minus 2bx minus 2b times x. Yeah, cool. So right hand column minus a cross ax minus 2bx, which is what that says, 2b minus ax in brackets, and then 2bx squared. So there you go, that's it. So that's why it becomes that x minus 1, 2bx plus a in your example. The letters in the exercise are different. It comes out as they use 2ys plus x and s minus 1, but same thing, isn't it? Okay, so that's that one, and then the final one was that one. This is actually a very, to me, important expression, probably the most important expression in maths, but most people don't know that it exists, I think, sometimes. So here we go. Two things that multiply to give x, alright, that's easy enough, x. And then two things that multiply to give y squared, s squared, and that's going to be sy, or ys, whichever way you want to do it. So that's those two lined up, and then if I look at all positives, so, and then that's xsy, and that's xy or xys, whichever way you want to put it. So that's xys plus xyx is 2xys, so there we go. So it's just sy plus x squared. It's actually known, some people call it a perfect square. I don't think that's a very good name. A better one is binomial square, because there's a pattern underneath. That pattern is, you might recognise from Pascal's triangle. We've got coefficients of 1, 2, and 1. And it comes up a lot, this pattern. That's why you've probably seen it, 1, 2, 1 in Pascal's triangle. So yeah, it's one to be aware of. So if you look up binomial square, and when you get to know it, it's handy because it comes up, as you can see, it's come up in this one. It comes up a lot. Okay, sorry this was so late, and I hope that was some use. My throat's gone, by the way. I've got another cold. You seem to catch me when I've got colds. Let me know if you found that useful. If you've got any questions, if I can help any further, just give me a shout.